Okay, last class we talked about, remember, the fundamental counting principle, which simply said that if there were, let me finish writing, fundamental counting principle. And we said that if we had two events and one could occur in M1 ways and the second could occur in M2 ways, that to find out how many possible ways those events could occur, we just multiply those together. So you did that on your homework. We also talked about permutations. And permutations are used when order is important. And remember, a permutation, if we had n events and we want order, where order is important, we could use n factorial, which was n times n minus 1 times n minus 2, all the way down to 1. That was n factorial. That is an example of permutations. We also talked about permutations possibly just using a portion of the total number available. Remember, we saw the formula total number, order's important, and we're taking them R at a time. For instance, we did the situation where we had 8 horses in a race, and we wanted to know how many ways they could come in first, second, and third. And so we could either do this on our calculator. If you go to Math, scroll over to Probability, and then hit Enter. I don't remember what number it was, but you'll see this NPR. You can plug that in. Or we could work it this way. If you want to work it longhand, that's 8 factorial over 8 minus 3 factorial. In fact, the formula here was n factorial over n minus r factorial for permutations. Just review so far. This would be the same as saying 8 factorial over 5 factorial, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 over 5 factorial, 5 times 4 times 3 times 2 times 1. Notice these all cancel. So we could have stopped it at 5 factorial over 5 factorial. Okay, then you just multiply your 8 times 7 times 6, and the other day we got 336. Just a quick example of permutations. Don't think we talked about distinguishable permutations. So we want to look at distinguishable. It means distinct or different. Distinguishable permutations. Best way to do that is to just give you an example. If we have the letters that spell banana, we want to know how many distinguishable or different ways that could happen. So the formula for distinguishable permutations, if you have n objects, in this case we have 1, 2, 3, 4, 5, 6 letters, and it has n1 of one kind. In other words, we have 1B, n2 of another. Here we have 3 A's, n3 of a third. And it could keep going. So we could just say etc. The number of distinguishable permutations and I'll just abbreviate permutations, is n factorial over n sub 1 factorial times n sub 2 factorial, all the way down to however many you have. So let's go back and think about our letters banana. We said that we have 6 letters, so if we use this formula, we'd have 6 factorial on top. We have 3 A's, so we could do 3 factorial. We have 2 N's, and we have 1 B. The order that we list them here does not matter. But let's see what happens if we work this out. We have 6 times 5 times 4 times 3 times 2 times 1 over 3 times 2 times 1 times 2 times 1. Let's see what we can cancel here. We know that the 2's will cancel and the 3's will cancel, and 2 goes into 4 2 times. So if we multiply what's left, we get 6 times 5 times 2 over 1, or 10 times 6, which is 60. There are 60 distinguishable permutations. Another way we could do this, if you didn't want to write out all the factorial, we could move this up. We could start with 6. 6 times 5 times 4 times 3 factorial, because if hopefully you recognize you've got a 3 factorial on the bottom. And then 2 factorial is 2 times 1 times 1. Well, the 3 factorials cancel. And 2 goes into 4 twice. And so we still get 60. Let's look at another example. Say that we have the letters. Okay, we just worked another one. We had 9 letters, so 9 factorial. We had 3 E's, 3 factorial, 2 A's, 2 factorial, 2 P's, 2 factorial, 1 J, and 1 R. When we listed those out, I stopped at 3 factorial because the 3's canceled, the 3 factorials canceled. 2 times 2 is 4, which canceled, and when we multiplied that out, we get 15,120. So remember, these are distinguishable permutations. Okay, we want to talk about combinations. That's where order is not important. We just may want a subset where it really doesn't matter about the order. We could use combinations of n elements taken r at a time. If we think about this combination of letters, this ABC, and I just change the order, if I change it to BAC, these are equivalent because it's the same 3 elements, the same 3 elements. The only thing that's different is order. And with a combination, I really don't care about order. I just want to know how many different combinations I can get out of those 3 letters. So let's think about if we have 4 letters to choose from. A, B, C, D, and E. I have 4 letters. I want to know how many different combinations, or how many ways, in how many ways can 3 letters be chosen that will give me a different combination. So let's see what we can do with that. First of all, we know that we could do ABC. If we think about a particular order, if we want to do it sequentially, then we could also do A, B, D, and A, B, E. Okay, so far I've got 3. Now, I'm looking at those 5 letters. If I could still start with A and have a CD, I could have ACE, and then I could also do ABE. DE. All right, now let's see what we can do if we leave off the A. Right, we could have BCD. We could have BCE. We could have BDE. Again, order's not important, or we could finally have CDE. So 3 letters can be chosen from those 5 letters in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different ways. Right, that can get a little bit cumbersome. We don't want to have to list everything out every time. It wasn't too bad with these 5, but just like there was a formula for permutations, there is a formula for combinations. The combination of n elements taken r at a time is, instead of NPR, we use NCR. Again, this formula is in your calculator, but it's n factorial over n minus r factorial times r factorial. So if you don't have a calculator handy, you can use this formula. So we had 5 elements earlier, taken 3 at a time. So we could use the formula rather than listing everything out. So we would have 5 factorial, and 5 minus 3 is 2 factorial over 3 factorial. So if we want to list this out, we have 5 times 4 times 3 factorial over 3 factorial times 2 times 1. Well, these cancel. 2 goes into 4 twice. And just like we counted them individually, here we also get 10. Using the formula can be a whole lot quicker for us. Okay, I left the formula at the top of the page. Let's do another one. This is probably something some of you might be interested in. A standard poker hand consists of 5 cards. And it's dealt from a deck of 52 cards. All right? And in this deck of 52 cards, you have 4 different types of cards. You've got your aces, your clubs, your spades, and your hearts, and you have 13 of each of those. So 13 times 4 would give you 52. I've been surprised that not everybody knows about the different suits in a hand of cards or in a deck of cards. So we want to know how many different poker hands, 5-card draw or whatever you want to call it, that we could get out of a standard deck of 52. So our formula would be 52 C taken 5 at a time. So we would have 52 factorial, and 52 minus 5 is 47 factorial times 5 factorial. You have it available on your calculator, math to probability, but this is not going to be too bad to write out. 52 times 51 times 50 times 49 times 48 times 47 factorial over 47 factorial times 5 times 4 times 3 times 2 times 1. Well, the 47 factorial cancels. We know that 5 goes into 50 10 times. 2 goes into that 10 5 times. 12, 4 times 3 is 12, that goes into 48 4 times, and you can multiply that out now, and you would find that you have 2,598,960 possible hands that you could get 5 cards from a deck of 52. Okay, if we want to form a 12-member team, we have a 12-member team, and we're going to form it from 10 girls and 15 boys. I want to know how many different teams are possible. I must have 5 girls and I must have 7 boys on the team. So what we would do is take our combination, 10 girls, 5 at a time, and multiply that by 15 boys, 7 at a time. All right, you can put this right into the calculator, and if you do that, you should get 252. Go to math, over to probability. Well, before you go there, hit 10 on your calculator, go to math, probability, choose the correct response, NCR. When your home screen shows up again, hit 5 and go through that process again, excuse me, to multiply the 2, and you should get 252. All right, your assignment is on page 697. (28 to 66 even).